All right, I'd like to start off with a question for Mr. Adam Schwem.
I'm here. What's your question?
Why are we waiting until Unit 12 to talk about something as important as save to disk?
Because I let you down.
No, that's not true at all. Tell me why, though. Tell me why not until now do we talk about this?
Really, because there's a combination, I think, of the way that Java works and the way that mobile works, where you want to make your things not persist state. You want to build things that don't persist state, and then only persist things that you need to actually save. Because otherwise, what would happen to a beginner is they would just save everything, and that's not good. On top of that, saving things is slow. And our applications should be incredibly adaptive to things that are out there. You don't really want to save all data. So I think we've waited, probably until this point because now they can do it responsibly.
Got it. Okay. So it's kind of like handing them the keys to the car, right?
Yeah.
It's just the keys to the disk.
Yeah, exactly. And we're gonna do it like the Java engineering way. We're gonna raw write this stuff. So what they're gonna do specifically in this one is really good. It's gonna there's gonna be a lot of try and catch. It's gonna be crazy. It's gonna be awesome.
Right. So the goal is to track two things. One is the number of times the application has been used.
Right.
And the other one is what's actually been entered.
Yeah.
In the application, like a notepad.
Like a notepad. Yeah. Mm-hmm. Yeah. And you have to be very careful when you do that stuff, right? Because that life cycle tears things down, at different points. So you got to pick the right time and place to save things. Because saving things can be very expensive. It could take a lot. It's not just like moving memory. It's actually writing to a disk of some sort. So this, by the way, I love this. This is one of my favorite. Thank you, Android, for making this so easy. If you just want to save something that would normally kind of be stuck in a bundle, right? So like an int or a string or something like that, you just get this object and go save it. And then it's like, I got it. And you're like, thanks, man. And then later you're like, hey, do you remember that thing? And he's like, sure do. And it's so simple in code. It's so good.
Why is it called shared preferences?
I don't know. I mean, shared preferences. Yeah, I don't know the reason for that. Okay. It might be that typically you would save things that you put kind of like in a preference file. But then the shared word throws me off because you're not really sharing it between applications.
Okay. Well, in that case, I'd like to issue a challenge to our users.
Okay.
I would like them to come up with an explanation as to why it's called shared preferences.
Okay.
They can do some research or they can just, free brain it.
Free brain it.
Free brain.
Yeah.
Yeah.
Okay.
And I'd love to see that on the discussion board. So that's your challenge, those of you listening.
So yeah, check that out, man. Check how easy that was. Like I did 2 lines of code. I read data. It's so cool. Like this app, you could have run the app.
What were the 2 lines? 41, 42?
Technically just 42. Actually, it was just one line.
Just one line.
Yeah. I'm doing an extra thing there. But yeah, just shared preferences.getInt. And in order to get the shared preferences object, you're just like get preferences. It's great.
It's almost like it just gives you a place to store stuff.
Yeah. Yeah. And it doesn't matter what happens to your app if you I guess if you remove it, it does actually go away. And then writing is a little bit more complicated. You have to get this thing called the editor. And in the editor, you then put things in it and say commit. And that's about it. So it's not that much different.
And they've already seen how this is used.
Yeah. Yeah, they better have. Otherwise, they skipped ahead.
Yeah. So reading and writing, it's simple. It's an object, obviously, but it's a specific type of object, the shared preferences object. And that object is going to store a lot of this data, or is going to kind of encapsulate a lot of this data.
And it's going to do all of it for you.
And you don't even have to worry about, how does it write it to disk? How does it, where on the disk does it save it?
Nope.
How does it, manage that memory?
Nope.
It just does it all.
Just does it all. All you have to do is say commit. You do have to commit. You have to make a commitment if you're going to persist something.
That's what I like the most about this, is the save to disk and the use of the word persistence. Because it's like you do have to ask yourself the question, what do you want to persist? What do you want to remain the same?
Yeah. Yeah, and when you when you try to write applications that persist everything, what you find out is that it's really hard to reset things.
Mm-hmm.
This time this was.
Did you goof?
Well, I mean, it's hard when you're trying to like show off like an app running for the first time, and you're like, oh, but I just wrote it and then I just ran it, and so we've already run it more than once. So yeah, I think this actual code along, I think I actually just got lost in the weeds here a couple times because I had to keep restarting it over and over again. But there we go. First time. Welcome to your new Magic Notepad.
Right.
So that's the easy way.
Okay. So we go the easy way first.
Save, restore. Yeah.
Is there a hard way?
I wouldn't say this is the hard way.
Less easy way.
This is the real way. This is where you can save whatever you want. And
before you were just saving ints and things like that.
Whatever shared preferences allowed me to do.
Okay.
This is some crazy stuff here. This is like not even just like, hey, here's how you read and write something that you want to store. Mm-hmm. This is how you read and write anything anywhere on the disk. If you wanted to go and read someone else's app and read data from there or on the SD card, or you wanted to start. Maybe you wanted to make an app that actually changes how the Android operating system works. Like you can do that with this technique, because this is literally connecting to files and changing them.
So what would make you choose this technique as opposed to the easy way that you described before, of where it handles it all for you?
Whether or not the easy, I mean, I'm pretty lazy sometimes, so I would just always choose the easy way until it couldn't do what I wanted to do.
Like what?
Well, for one, I can't specify where the file is. Like maybe I wanted to download several different files from the internet and then read them into the application. Can't do that with shared preferences. Sorry, shared preferences, you can't do everything. But you could, or maybe I wanted to like actually change the contents of another piece on the Android phone. Change user settings or something like that. In this case, also, it makes it easier to debug. If I'm going to actually like save like a Notepad thing to file, then I can always kind of like go into my phone and look at like what was actually saved and troubleshoot and debug that.
Okay. So I think I kind of get it. Now, as you're implementing it, you don't have reading and writing separate. You have reading and writing.
Well, right now we're just doing writing.
Okay.
So save text file will write it, and then get text file will read it.
Mm-hmm. But get text file you have as return null.
That's how it starts.
Okay.
That's how the project starts, and then they have to fill it in. So this is the structure you want to use when you're doing this. Reading and writing to file can get really crazy because you don't know what's going to happen when. Oh, check that out. Flip flop.
Why'd you do that?
Because a file not found exception is an IO exception. So when I caught the IO exception before it,
it would have caught it twice.
And it was giving me an error. It's like, you can't do that. You already caught that one. So this now it's like, if it's file not found, go there. But if it's
specific type of.
Yeah.
Yeah. And again, you couldn't add the apostrophe to couldn't.
Right.
Because you don't like apostrophes.
I hate them.
Yeah.
Yeah.
No, it's fair.
Now this looks a little crazy with all the nested things, but believe it or not, this is actually how you should be writing this.
Try, catch, finally, try, if, catch.
Yeah.
But finally is not, it's weird because you said finally, but then you had another try, catch.
Right. Well, the try catch is inside the finally.
Yeah.
Because no matter what, this is going to guarantee that we close our output stream. We don't want to leave things hanging. They never really had to deal with this before, where you have to kind of clean up after yourself. But like when you're starting to deal with shared resources like the disk, you don't want to leave those kind of handlers open and exposed. So here, you're going to watch as I take the writing and turn it into the reading by just changing, so you can kind of see the difference between the two and how they're similar.
Tell me a little bit as you go through this, and they can see where you're making adjustments to the code you copied in here. Tell me a little bit about this idea of a stream.
Right.
Or read.
A stream. Okay, so when you have data, not data. When you have a process that you're going to do, and that process is not necessarily going to happen all at once. It's not like you just like, I have data. Like with all these method calls, we're always like, there's the data. But when you go to like the disk or the network, like you're going to have to do it in chunks. Like give me some, and then I'll handle it, and then later when you have more, then I'll handle that. So this kind of asynchronous stuff, you really need to have kind of streams as a concept. And so what that really is basically taking a bucket that we call a buffer and filling it up and dealing with it.
Okay. So is the stream happening practically simultaneously? Is it coming in over time?
Well, okay, let me put it this way. Let's say you wanted to have some water in your house. Let's say your water main is off.
Yeah.
So you open your window. That would be kind of like opening a stream. And then what would happen is when you'd call me on the tin can antenna, right? And you'd say, hey, give me buckets of water because I don't have any. And so I would come over and I'd give you a bucket through the window. And then you might pour that into your washer and dryer, and then I give you another bucket, and you'd use that to So you constantly have these buckets of water. I couldn't just take my pool and just be like whoosh right through the window.
You have a pool?
I don't have a pool.
You haven't invited me over?
Which is strange. Yes, I know. Being that we share a backyard.
No, I get it. You're basically saying that yes, it comes in chunks, but not necessarily all the chunks that you want at once.
Right. So in here, we're reading that stuff in, and again, after I give you all your buckets of water through your window, you want to close your window, right? You don't want to leave your house just unlocked and let anybody just kind of crawl in there and steal your water.
Steal my buckets.
Yeah, steal your buckets of water.
Yeah.
So yeah, that's kind of what we're dealing with the streams.
Mm-hmm. So there's been a lot added now.
Yes.
In just our little stream talk.
Yeah.
Read and close obviously goes with what we were just saying.
Well, this is a little different because when you write something to file, you basically take whatever format it's in and write the bytes. Here we actually have to take an unknown format of bytes and turn it into a string. We know it's a string. So we have to read it in. We have to know how big it is because we need in Java to know like how much memory should we allocate for this data. Then we also have to convert it because those bits of ones and zeros, they're not numbers for us. They're actually representing characters. So we have to now convert that into a string.
Right.
So that's kind of all the stuff we did there. And now here, if they got this far, that's great. But I'm really curious what their instinct would have been about where to save and restore the text file. Because here I'm doing it on resume. That gives me a really, as long as my Notepad isn't too huge, this gives me a really responsive application in the sense that if anything interrupts this app, immediately it's just going to save its state to disk.
Where would you be pleased with, and where would you be not so pleased with them putting it?
I would be displeased if they put it just like randomly in their code and it didn't compile. That would make me feel... That would be the worst. That would be the worst.
Okay.
Next worst would be if they put it like in maybe on create and on destroy. I'd be very disappointed with the on destroy because that one doesn't always get called.
Right.
Then basically as you move up through the activity life cycle, I get happier and happier. Okay. The closer that they put it, I get happier and happier. So even
less displeased and more pleasure.
Yeah. On start and on stop would have been fine too. I would have been like, that's pretty good. And here I am writing in my diary that I just made.
There you go.
Yeah. It was a good day.
That's good. Sparks.
Yeah. And we'll see if it's a good day.
You just quoted yourself now.
Is it still there? It is.
It is. Yeah. Excellent.
Cool.
So one thing before we leave off here, I just want to ask this question about this concept of the stream and the reading and the writing being a different process.
Yeah.
So what I really liked that you pointed out was that writing you know what the information is. You know what the data looks like when you're writing.
Yeah.
And so you access the file input stream a little differently.
Output stream.
The output stream a little differently. And so when you're reading data, though, you don't know necessarily what the data is.
Not if it's just like a raw format. Yeah.
Right. And so there's this subtle thing where you have to kind of, even if as a programmer, you know exactly what kind of data you're dealing with, you still have to treat it in code like you don't.
Oh, actually, no. Okay. So that's a really important point. Less important right now with the disk writing and reading. Mm-hmm. Super important when we get to network stuff.
Okay.
Because one of the things you can't do as a programmer is you can't, I know it's different with people, but as a programmer, you can't trust people. Because when you get data and someone tells you that it's going to come in a certain format, sometimes it won't. And that's going to make your stuff break because you're making an assumption that whatever, hey, I asked for a web page. Well, then why did I not get a web page? I just got a 404 message or, whatever. So especially when we get into networking, you have to be really skeptical of what data format things are in that you did not create. Because the minute it's outside your safe little closed system, it is suspicious. And you need to validate it and check it and make sure that all that stuff, one, doesn't screw you over for security reasons by someone kind of, giving you bad data and breaking your application and, security risks. But two, also, you want to deal with data that is odd gracefully and be like, oh, right, that was saved in a file format that I created 2 years ago. That's okay. We just have to read it in a different way, but we've adopted and changed the format. So,
Right.
So, yeah, that kind of distrust of data is actually really, really important.
I think that's one of those novice pro things. Like pros distrust the data they get from other sources.
Absolutely.
And novices are like, oh, that should be this, so I'll just treat it that way.
Right. Which is why most of the time when you look at like pros when they're debugging something, they just want to see the raw data. Like they're like, look, I know you said that was that. Just show me literally what is in memory. I will figure out where the error is from there.
Right. Got it. So they should be keeping that in the back of their mind as they head towards networking.
They should.
Excellent.
Yeah.